new pod is about to be created, but this one will crash the system. Look at the dashboard, red alert pulses. Something is missing. Hey folks, meet our new pod, frontend V2. It is created by the deployment controller. The pod is born and ready for its journey through the cluster. The pod arrives at the scheduler, the first gate. The scheduler finds a suitable node based on resources and constraints. The pod is assigned to node T3. The pod moves into its assigned node 3. The container runtime pulls the image and starts the container. Our pod is now running and serving traffic. But look closely. This pod has no resource requests or limits. It can consume any CPU and memory on the node. Under high load, this becomes a dangerous bottleneck. Traffic spikes. The pod's CPU usage skyrockets, consuming all available resources on the node. This is the dangerous zone. Resource pressure builds, other pods get throttled, the node runs out of memory, the oomkiller terminates our pod. It enters a crash loop, restarting, failing, restarting again. The front end goes down. Users see errors. Let's debug. We check the pod logs. It crashed with out of memory. Then we examine resource metrics, no limit set. The node was overloaded. The root cause is clear, missing resource request and limits. We add resource requests and limits to the pod spec. We also add a readiness probe that checks if the container is truly ready. This protects the pod from resource starvation and ensures traffic only goes to healthy pods. We redeploy with the new spec. The pod is created, passes the scheduler, lands on a node, and passes the readiness probe. It's marked running and starts serving traffic without overloading the node. This is the final architecture. The deployment creates pods with resource requests and limits. The scheduler places them wisely. The node hosts pods that are protected by a readiness probe, ensuring only healthy pods serve traffic. Software objects do not fail mysteriously. The system fails them where the engineering guard was missing. Add resource limits and probes. That's the difference between a crash loop and a robust service. If this helped, subscribe for more system design insights. If you enjoyed this deep dive into Kubernetes pod lifecycle, hit like and subscribe. See you in the next one.